Hello Matrix, welcome to another video. So here we're going to be dealing with the paper 1 2015. So due to time constraints, I don't think I will be able to do more than just a paper. So let me just get everything ready. Where's my calculator? Right, it's all set. So now what we're going to do is paper 1. At least we're just going to do one paper. I think when I looked through these papers, I found that this paper from 2015 was pretty much, a good paper to learn a lot, at the same time to practice some challenging questions as well. All right, let's go on. Question 2. It says two blocks of mass M and 2.5 kgs respectively are connected by a light inextensible string, meaning it does not dissipate any forces or any work whatsoever. The string runs over a light frictionless, so also this does not dissipate any work or forces, pulley as shown in the diagram. So we have this diagram over there. We can see that this mass is lying on the surface of the table and that one is hanging and it's connected to that by the tension. Now to pay attention is that the tension on this string at this point, it's T and it's directed to the right, and then the tension T in connection with this box is directed upwards. Because this pulley system is frictionless, it means the tension over there is going to be the same as the tension over there, and then we will have the weight of this just a second. Okay, so that is taken care of. Sorry, it was just the people who cut the grass, so they just had to take care of them. Alright, no problem. And then, now we know that the driving force here should be this weight, but we are told these blocks are stationary, meaning there is no movement. That means something is balancing out the system. Now it says state Newton's third law in words. Okay, so we're not going to waste time here. Question 2, and don't focus too much on my writing. It's not the best writing ever. So we have now 2.1.1. Now Newton's third law says if an object, okay, my writing is ugly, exerts a force on another object, the other object also exerts an equal force, but in the opposite direction. Okay, good. So it says if a body exerts a force on another object, the other object also exerts an equal force, but in the opposite direction. Okay, to the original object, of course. I mean, you cannot overly explain things, so sometimes when you've said what is sensible, it should be enough. So they're giving 2 marks there. Again, when you are asked to to state a particular law, it is safer to say it as written in the book. But if you do have an understanding of it, then you can use your own words. But I would advise you to always try to use more of your words and your understanding in this. But at the same time, do not run away from don't run away from stating things properly as well. Make sure you don't take the sense out of them. Alright, so now it says calculate the tension on the string. Okay, T. And we know that, okay, there's two options here. For us to calculate the tension on the string, we need this box. But this box does not have a mass, so we cannot use it. But this one has a mass, and we know its weight, so we can use this hanging section, because whatever tension we get here is going to be the same as over there. So not a problem. So 2.2, we're just focusing on the 2.5 kg block. All right, so the tension T is directed upwards on this block, and then the weight, which equals mg, is going to be directed downwards. And then of course these are stationary. When they are stationary, these two are equal. So all we can say now is that T equals W. Alright, if you want to say, you can say the object, or since the object is stationary. Great stuff, so you're good. So why are we saying this now? T equals, now W is mg. The mass was 2.5 kgs multiplied by 9.8, which is the gravitational acceleration. So it's 2.5 times 9.8, and we have 24.5 newtons. But now the tension, if we're looking in terms of this, it's directed upward. But for the m kilogram block, it is directed to the right. So pay attention to directions. Remember, when you're dealing with vectors, never forget to state the direction, because if you do, you may find yourself struggling to do most of the calculations, because everything here needs to have a clear direction. Alright, not a problem. So the tension on the string is this one. So they said 3 marks. Well, the most important is that statement over there, then the substitution and the answer, I think. So physics is fairly nice in that if you write the correct formulas, I mean, we cannot mark you twice. If you like, you can give a half a mark and a half a mark for that one. Okay, not a problem. So we know now the tension, as much as we found it to be, it's going to be the same, because this pulley system does not dissipate, and the string is inextensible as well. Alright, now it says the coefficient of static friction. Now static friction meaning the force that you need to initiate a motion here. It has to overpower the frictional force, I mean the static friction, between the unknown mass and the table surface is 0.2. Alright, so now somebody already wrote here that frictional force, the static friction, is going to be the coefficient multiplied by the normal force for this one. So the question says calculate the minimum value of m that will prevent the blocks from moving, meaning they want the mass. Alright, we don't have a problem. We can do this one. 1.3. Now we need to consider this block, this m block. Alright, it will have its weight, okay, and it will have the normal force directed that way, and then there's a tension on the string directed that way, which we now know from above it's 24.5 newtons to the right. And then of course there's going to be friction, of course, here, which is what we want. Alright, so we can call it Fs, because we can say it's static friction. Alright, not a problem. So now we are supposed to calculate the mass. It's not a problem because this is stationary, so we know very well that this block is stationary. It's still in that instance where this is stationary. So that means the tension equals the static friction. So we'll start there and say fine. The friction or static friction, I'm going to use Fs to denote that, equals the tension. Again, you can still say the same reason, since the block is stationary. But you don't really need to explain these things. They are implied as well. So if you state this, it's good enough here. So you're not doing geometry all anew, but sometimes it's good to express that you really understand. So now this implies now that our Fs equals the tension, which is now 24,5. Okay. But what do we know about this situation over here? We know now that friction is given by this coefficient of static friction multiplied by the normal force. Okay, this now gives us 24,5. all right, again, these two, there's no movement downward or upward, so they are balanced. So the normal force equals the weight. So we're going to work towards that. All right, so this is now implying the kinetic friction. They told us that it's 0,2. Not kinetic, sorry, static friction times n equals 24,5. Maybe I'm doing too many. Therefore, we're just going to divide here. 24 divided by 0,2. So 24,5 divided by 0,2. It gives us 122,5. Remember, this is newtons. And which direction is the normal force? It's upward. Always make a habit when you're dealing with vectors to indicate the direction. Okay, you can say upwards in words, or you write it down. We have a but we know that the weight of the M block equals its normal force. All right. Again, this is balanced, okay? And now we know that this is going to be the M, which we don't know, multiplied by, remember the weight is multiplied by the gravitational acceleration, which is 9,8, equals the normal force here, which is 122,5 newtons. All right? Okay, so we said that, and then it implies the following. Therefore, we can say now safely M equals, so it's going to be that 122,5 divided by 9,8. And then what I get here is 12,5 kgs. Remember, the mass in this calculation is in kilograms. Yes, it is so. Not a problem. So you see, it's a little bit of a geometry-like. So physics is like mathematics in geometry, but you need to be very strategic. At the same time, do not distort their diagrams or their implications. So again here, we were told we're getting 5 marks. Fine, we don't have a problem. I think to make that declaration, it is very important, okay? And I think to really get to this stage, I don't know, maybe to get to that stage it's another mark, and then to get our normal force it's another mark. So we have 3 marks over there, and then to state this, it is very important, and then of course the final answer. So, well, it's sometimes very controversial where the marks are, but you can just say to yourself, if you are confident enough and you know you've gotten it right, doesn't matter where these marks are sitting. But if somehow you didn't get to the answer, then you want to make sure you show each and every step you have made, even if you're not sure, because you might have just made a slight error, or at least you get stuck somewhere, but having started all right, so you get your marks there. Try not to get 0 in any question if possible. Okay, so that's fine. I'm not going to spend too much time. So that is done. Oh, no, not done. Oh, okay, now they're changing the scenario again. So these are big hitters. The block of unknown mass, M, is now replaced with a block of mass, 5 kgs. So now once you change this, to a 5 kilogram mass. Remember, what was the mass that we needed to stop the system from moving? That was 12,5. So now if you put in the 5 kg, obviously there's going to be movement. Most likely acceleration to the right for the M block, the 5 kg block, and then the 2.5 is going to accelerate downwards. Okay. Now we're being told also that the coefficient of kinetic friction, UK, between the 5 kilogram block and the surface of the table is 0.15. Remember now, kinetic friction is the constant frictional force that will be constantly applied as that system moves until that box falls off that table. Alright? So kinetic, it has something to do with motion. Static, it's something that has to do with just being at rest, meaning you have to overcome that before you can initiate movement. But once you initiate movement, there's going to be a portion that will be kinetic friction. These two are similar, very difficult to differentiate, but yeah, I hope you get the idea. Anyway, so now we know that we no longer have that scenario there. So we have 2.1.4. Okay, 2.1.4. So now we know we have this box now. It's 5 kgs. And it's connected through that pulley system. So this one is resting on that table. Okay, this pulley system over here, it's going to suspend this 2.5 kg block. Alright, and then of course, that being our table. Sometimes to draw it's nice, but it's not really necessary, of course. So we have a tension there, which is certainly the same as tension over there because of that frictionless pulley system. Now there's kinetic friction here. Now we can write Fk here to signify the kinetic friction. There's going to be kinetic friction. And okay, let's just leave the diagram and not complicate it further. So this one is going to be the weight of this 2 kilogram box, which is mg, and then we know that we calculated 24.5 newtons. All right, but you can do the calculations if you want. It's not really a big deal. So this is now the new scenario. And now we are told to calculate the acceleration of the 5 kg block. You see, always pay attention to what the question is saying. Basically, we want the acceleration of the system, but we're going to use our 5 kg block as reference. Okay, but now remember, this is a new scenario now. It's not going to be the same as upward, so forget that tension you calculated. It's no longer the same because now there's movement, so the tension is not going to be the same. Okay, so we're going to start and say, fine, we will consider these two blocks as a unit or a system. Okay, because we don't want to have too many opposing forces. So we're going to say, okay, fine, we will consider these two blocks as a unit. So this is like better to do this way, like to connect these two. So meaning the mass in this system is going to be these two blocks together. And then we have friction opposing the motion in that direction, and then we have the weight pulling, so it's stronger. This is certainly Newton's second law of motion, so we don't have to worry about a lot of things. So from here, we don't need to concern ourselves with the tension here. We're going to say just the resultant force, because this is Newton's second law now of motion, equals what? The mass multiplied by the acceleration. So F rest means resultant force. But we know the weight of the 2 kg, so it's going to be the driving force. So the W here of the 2 kg block, I don't know how to denote this one, but let's just say 2 kg minus the frictional force there, which is going to be Fk, okay, equals these masses together, which is 5 plus 2.5 kgs, and then times the acceleration, which is the unknown. Alright, not a problem. So we already know that the weight of this 2 kilogram block is 24.5. So we will have 24.5 minus Now this one, it's going to be this kinetic friction multiplied by the normal force, okay, of that 5 kg block. Not a problem. Which equals, this is 7,5 A, okay, because we still want the acceleration. Alright, maybe I should have said imply, which also implies that we have 24,5 minus, inside here we have 0,15 multiplied by, remember now, the normal force here, it's going to be the weight of that object because it's not falling down, it's not being lifted up. So those two are balanced until it falls off. So it's going to be that now 5 kg block multiplied by 9,8, which is essentially the weight. So we're just going to do that complex calculation, equals 7,5 A. We're trying to be as comprehensive as possible to avoid multiple steps, but if you can't, don't panic. 24,5 minus, now we're going to do that one. Say 5 times 9,8 is 49 times 0,15. I hope I'm doing the right thing, yes, which is now 7,35. Alright, remember that was newtons, but don't worry about the units so far. Equals, and then 7,5 A. Alright, this implies, now you can make this one lead, 7,5 A equals, then of course we take that from 24,5. And then what we have here is 17,15. Alright, great stuff. Therefore the acceleration is going to be this one divided by that. So here I get 2,2866, so it's going to be 2,9 basically. 2,29. This is 9. I'm sorry for the way it looks, meters per second squared. Remember, acceleration is meters per second squared. But now they said for the 5 kg block, so it's going to be to the right because it will accelerate in that direction. Or you can say eastwards, or you can just use the arrow, which I prefer a whole lot than the words that are too many. Sometimes too many words can mess up a lot of good stuff. So you just want to indicate. I think they say action is better than words. Okay, not a problem. So you can see it's a very complex situation, but I've tried to at least save a lot of time. But you need to know these things. You can split them apart and first calculate the friction alone, the kinetic friction, and then eventually use your Newton's laws of motion. It's still okay, but I mean, this is the best approach. You can do this. Okay, so for the formula, Newton's second law, proper stuff. And then we will essentially award a mark for this situation. I mean, this whole situation is very important. But this one deserves a mark. I don't know, you can give it there or you can give it here, because this is indeed very important. So you can get a mark here. Maybe let's say for eventually writing out this formula. It's very important as well. So formulae in physics are quite a wonder. And then of course either the answers or the substitutions, depending on how many marks there are. But remember, an answer is never complete for a vector if you do not indicate the direction. But there's the 5 marks. Alright, not a problem. So we've killed that question nicely. But if you have a further question, you can technically split these two apart. You consider this one alone and calculate the tension. You consider that one in the way of calculating the tension, of course considering the friction. And then, because these are the same, then you will equate the two, and eventually it will land you to this answer. Okay, but it's a bit more longer. Okay, let's do the last one, which is 2.2. So 2.2 says, alright, a small hypothetical planet has a mass of 6,5 times 10 to the 20 kgs and a radius of 550 kilometers. Calculate the gravitational force or weight that planet X exerts on a 90 kilogram block on this planet's surface. Okay, no problem. So this is Newton's law of universal gravitation. So we want the attraction force. Remember, the Newton's law universal gravitation situation, it only talks about attraction, never about repulsion, okay? Unless really it's some crazy situation I have never had, but the practicality of that is just attraction. So here we're not going to waste our time. We're going to just say force equals, the force meaning gravitational force, we can say Fg if you will, is going to be the big letter G, which is the universal gravitation constant. And then it's going to be mass 1, mass 2. Where's my ruler? Why do my rulers keep disappearing? Yay! I don't want to be angry at myself. So over r squared, okay? That's what we do. And then you need to know this by heart, but if you don't, you just look up in your book, in your information sheet. It's basically 6,67 times 10 to the minus 11. Of course, forget the units, but if you look at them though, at some point, some questions may demand that you know these units. Luckily, they've written them out in that information sheet, so you won't struggle a lot. And then M1, we can use the 90 kg multiplied by the mass of this planet. They said 6,5, right? I hope I'm right. Yes, 6,5 times 10 to the 20. So it's a very big number. All right. That's okay. We can take this. All of it divide by the r squared, which is the radius. It's 550 times 10 cubed. Remember, this is 1,000. There's about 1,000 meters in a kilometer. So that's why we multiply by 1,000 and then we square that one. Alright, so we're just trying to save wasting time here. There's nothing really special. They've given you everything. It's like a standard grade question back in the days. Alright, so now we can just do the calculation. It's 6,67 to the minus 11 into 90 into 6,5 to the 20. Divide by 550 to the 3, okay? And then we square that one. And then let's see what we get. So my answer is 12,8. Okay, it's 12,899. Again, to two decimal places is going to be 90 newtons. And then of course this is attraction, because it cannot be a repulsion, because we know that the weight simply talks about attraction. Okay, we are good. So we're not going to say too much here. There's a lot of work to do. Of course, you know, in physics, the formula, getting the right one, copying it correctly, awards marks, and then the correct substitution gives you another mark. But remember, you converted kilometers to meters, so you will get a mark for that conversion. So if you've done any event in physics, you get a mark. So when you say big marks, sometimes don't panic and think you need to do a lot. Just make sure you're paying attention to small things that you need to do. And then of course, the answer. Remember this answer, force is a vector, so the direction. So attraction doesn't matter, because it's attracted towards the center of the planet, okay? You can even write attraction towards the center of the planet, but attraction is good enough because it just tells us the direction of this force. So this is 4 marks, which is the mark on offer for that question. So we have taken our first 19 marks pretty easily. Okay, maybe the one challenging question would be this one, but I mean it's the same as was in the olden days, but the one thing that is probably new is these kinetic coefficients. I mean, these coefficients of kinetic friction or static friction, those are the things that we were not really doing. we would be told what is the frictional force, or at least be told to calculate it given certain parameters. Now they actually ask you to calculate it indeed, and that kinetic friction basically is the ratio of the actual friction and the normal force. Okay, so that's why normal force has a very good play into this. Alright, not a problem. We are done with this part, so let's put it away and say thank you very much for a nice question. So always get this question right, but it can challenge you, so do not take it lightly either. It's not easy, but yeah, marks can be banked a lot in that first question. Okay, let's do question 3. It says a ball is projected vertically upwards. Once you hear this, it's projectile motion. Back in our days, they used to commonly refer to it as falling bodies. But the idea was that with this kind of motion, we know that there's only one force at play here, the gravitational force, and therefore the acceleration is always there, is the gravitational acceleration. On the motion up, it's a deceleration due to gravity, and on the way down, it's an acceleration due to gravity. Okay, so nothing changes there. Now it says this ball is projected at 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as zero reference. Okay, not a problem. It says now calculate the time taken by the ball to return to the ground. Okay, 4 marks. So not a problem. Again, here we don't want to stress ourselves too much. We will just get to it and see how far we go. But I will try to make the video not longer than an hour. If I have, at least it won't get to 2 hours. I'll chop it into 2 sections just to avoid a very long and tiring situation. Okay, not a problem. So now we have this ball, which is ball A. It's projected upward. It's going to go and reach its max. Okay, and then from there it's going to come back down. Okay, and it's still going to be ball A again over there. Of course, this is now ground zero, the horizontal surface. Now we know that it is projected upward, so we can choose that up is positive and down is negative. Just do those arrows and indicate if you don't want to write. And then we know, okay, there will be this displacement over there, which is fine. We're not interested in it at the moment. But we know that this left at 16 meters per second. If it left at 16 meters per second, it will arrive at minus 16 meters per second. Remember, with falling bodies or projectile motion, the level at which the ball was released, when it comes back to it, it will be coming back right at the same speed, but in the opposite direction. That's why I'm writing minus 16, because we chose upward as positive. But at the Vmax there, or should we say right at the turning point, the V is 0 meters per second, because this is when it stops and then turns back down. Again, we know that if it took t seconds to get to the top, it will also take t seconds to come back down, or at least to the same level. But thankfully here, this one was not thrown at a height, but from the ground, so it is just nice. Not a problem. So we have 2 options here. We don't know the time, okay, that it took, and that's what we want. So we want the total time, or we can calculate half of the time and multiply it by 2. It's up to us. So let's just go on and say we know for a fact that V equals U plus gt. Remember, now with projectile motion, the acceleration is replaced by gt. Okay, now we know the final velocity is minus 16 equals 16. U means initial velocity, so I don't know this. You have your formula though, so that you can write it correctly the way they want it. I'm sorry, I'm not used to this. It freaks me out. Excuse my expression there. Now this is negative because the acceleration is negative. It's going to be 9,8 t. Alright, so we now know very well that, okay, we can just take this one that side and take this one this side. So if we do this, we know now that 9,8 t equals 16 plus 16. All right. Therefore, t equals the division thereof. So 32 divided by 9,8 gives me 3,27 seconds to 2 decimal places, of course. Now, this is the total time it took. Okay? So this formula pretty much solves our pain. But we know that the time it takes to reach its maximum is going to be the same time as it takes to come back down. But time being a scalar quantity, we don't have to worry about signs. But if you chose your signs very well, you'll see it will just come back nicely positive. You won't have to adjust it. But if it came back negative, if you looked at this section, it's still okay. Time is never given a direction. So time is a scalar quantity, so you just give it as it is. So you don't worry about too much and the signs. Okay, so again they gave us 4 marks. So the formula and then the correct substitution, of course paying attention to the signs, and the answer. Whoa, what am I doing? Okay, this velocity is important because it was never there. You had to imagine it. So if you show on your diagram, no one is going to punish you. So if you don't, then sometimes you have to state now that the velocity at which the ball will return to the ground will be the same as the one it left the ground. Okay, so there's the 4 marks. Okay, alright, not a problem. But in this instance, I would like to propose another way of calculating this, because I feel sometimes certain ways are better than others. Okay, let's look at this and say, fine, we want to know the time it took from the time it was projected to the maximum or to the turning point. So it's still going to be the same, v equals to u plus gt, okay, because it's gravity now. The velocity there is 0 at max. Okay, we don't have to worry about 16 minus 9,8 t. Okay, we can therefore say t will equal, so if we take this one to the other side and then we divide by 9,8, it's just going to be 16 divided by 9,8, which is 1,63 seconds. All right, not a problem, because this is the time it took to reach maximum. Therefore, you can say t tot, meaning the total time, is going to be 2 times 1,63. Now let's see what is that. 2 times 1,63, it gives us 3,26 seconds. Okay, you can see it's comparable to that one. So this method, it's still okay. You can use this one and there's no harm. But either way, you need to know that you have an answer for the formula there, correct substitution. But because you didn't, okay, let's say here, you will get a mark for that one. We won't necessarily mark the 0. And then for this final answer, you get the 4th mark. So do you see, you can have more than one way of looking at this. So this is, or it's an option. Of course, there's usually plentiful options in which you can do this, but I think this one is concise. This one maybe involves 2 steps. It needs you to understand at the time. But again, you would know, even if you wanted the time it took to get to the highest point, you could just simply do this and then divide it by 2. It will give you the other half. Not a problem. So 3.2. So it says, sketch the velocity versus time graph for ball A. Show the following: the initial velocity to reach the highest point of the motion, the time taken to reach the heights, the time taken to return to the ground. Okay, so 3 things they want from us. Okay, we can handle that. It's really nothing. It's really nothing. Okay, so let's do our x's. We don't have a problem. But pay attention when you're doing this kind of a situation. If you remember from grade 11, I don't know where you guys do the graphs and equations of motion, but either way, If you remember from that time, you would know that you will require positives and negatives, because when they say velocity, you need to consider the positive and the negative end. But if they just said speed, you don't need the negative side, because speed is never negative. Alright, it's a scalar quantity, but velocity is a vector quantity. Okay, so we can just make I do not know, so 1 to 8, and then we can make up to 4 the midpoint, just to stretch it out a bit, and then there we say this is the last part. Okay, no issues. This is very simple, so do not make a mistake. So this is the time in seconds, so you indicate your axis, not time in seconds. You can just put that in brackets. And then for this one, you just need things that are going to be symmetrical on either side also. So if we choose this one, say we're going to centimeters to the other side, we're going to do the same here. I hope I'm not going too far. Doesn't look like I am. Okay, so that's fine. Mind you, this is 0. So in terms of time, halfway, it's the time it takes to reach the maximum, which is this moment here. See, this one is the best if you're asked this question. So you know here you have 1,63 seconds, because they want us to show them the time it reached the highest point, and then when it returned to the ground it was 3,26 seconds. Okay, you indicate those values, and then of course the velocity that it was projected with, we chose upward as positive, so here you're going to write velocity in meters per second. You just write the SI unit in brackets if you want. So we know that that was 16. This one is going to be minus 16, which is the return to the ground. And then all we need to do is that the velocity dropped from that 16 to 0 at that time. And then it continued to climb until it reached yet that point over there. So we can simply say now, okay, we are sorted, because that's all we need. We just need to connect the dots now. Nothing else is left. So let's use another color instead, so that we don't have a situation where we can't differentiate between the two. So there's our graph. So this is the time when it has returned to the ground at the same speed that it was projected upwards on. And then of course that one is covered there. So we've stated that velocity at which it returns to the ground and the velocity at which it left the ground. At the midpoint the velocity was 0 and the time was half the total time, which is 1,63. Okay, so we've labeled it properly, so I suppose we have 4 marks there, because they wanted this and then the time to return to the ground and the velocity with which it left the ground. Okay, so not a problem. So we have our 3 marks over there. Easy 7 marks. Okay, so now let's go. It says now they always have these silly questions with the mechanics, so always make sure you master them, because if you don't, it's gonna be a very uncomfortable thing to do. Now it says 1 second after ball A is projected upwards. Okay, a second ball B is thrown vertically downwards at a velocity of 9 meters per second from a balcony 30 meters above the ground. Refer to the diagram below. Okay, we can see now that this balcony was 30 meters above the ground and that ball was dropped, but this one was only dropped while this one was already in the air. Now the question says calculate how high above the ground ball A will be at the instant the 2 balls pass each other. Okay, it's not a problem. One of those silly questions in life, but yeah, we take them and do the best that we can. 3.3. Okay, let's keep going. Now 3.3 demands that we do this. Now we know at some point that, okay, this situation, I'm just going to draw a rough sketch now. This situation is 30 meters, alright? And then ball A was already in the air for over a second. Alright? It was already some distance elsewhere from the ground, of course, when ball B was released. Okay? Downward. Okay? But we know they will be somewhere there. So there's going to be B besides ball A, depending on which one you're putting ahead. So they will have moved a similar distance from the ground eventually. Okay? Not a problem. So we want to find out here, what is that distance from the ground when this ball A is passing that ball. But this ball is a second later than this ball. Alright? That one is accelerating, so the velocity is going to be minus 9 meters per second, because we chose upward as upward as positive and downward as negative. So this one, when it left here on its way up, it was 16 meters per second. Alright, not a problem. So we have that situation. Now we need to derive simultaneous equations, because what would be key to this situation is us finding the time. We know that it will be the time t here. So if you write now, we can just say let the time that the two balls pass each other be t. Because if we don't consider this, we may have a problem, because we'll have too many unknowns. We don't know the velocities at which they will be traveling at that time. We really do not know the height. We don't know the time. So we need to try something here. Something that is easy to get. Time. Okay? And also the displacement. You can put displacement and time together because they give us the velocity. So you see, sometimes being strategic helps. Now, this implies that now the displacement, I'm going to use the letter S. I don't know how you use it. You call delta X or whatever. So the displacement of A. Back in our time when we used these equations, S meant displacement. Okay? But it also meant the second. So maybe that's why they changed it and said delta X. I don't know. It doesn't matter what. But now here we don't know the time. But this one is ahead by 1 second. So we're going to say it's going to be ut plus half gt squared, because you see this one captures the initial velocity, the acceleration, and the time and the distance. So we need these things together, which now we can say 16t minus, now a half of 9,8 is 4,9. Now I'm tired of writing a lot of things, so you'll forgive me, times t squared. Okay, now we cannot take this one further down, so this is equation 1. Alright, and then it also implies that SB equals, again, the same ut plus half gt squared, which now it's going to be minus 9 into, now remember this is a second later, so whatever the time it took for them, you will subtract a second. That will be the time traveled by ball B. So it's going to be t minus 1. Alright, minus this situation here, it's going to be 4,9 into t minus 1 squared. Okay, great stuff. So here you're back at algebra. Here you multiply, it's going to be minus 9t plus 9. Okay, and then here minus 4,9 into, then we work this fraction, this quadratic here, it's going to be t squared minus 2t plus 1. If you don't know how to do this, do the long method, which is to expand this and then do the multiplication. Eventually we'll get here, but when you are comfortable with that, you just quickly get to this one. Alright, not a problem, so let's keep going. So this is going to be minus 9t plus 9. minus 4,9 t squared plus 4,9 times 2 is 9,8 t minus 4,9. Alright, not a problem. So we further simplify this. Now we know that 9,8 minus 9, because the t's are going together, it's going to be just 0,8 t. And then 9, okay, let's just pull this one because it's without any friend to tie it to. And then minus 9 minus 4,9. Let's check. It's 4,1, I think. 9 minus 4,9. Yes, it's 4,1. So it's plus 4,1. And then here we don't want to move any further. We can call this one equation 2. So this is a bit extensive. So what we can say here, we know that, look, this displacement is going to be negative. Why? Because of the direction of the initial velocity and its acceleration. So this thing is negative. Alright? Essentially, it is negative. And then we know also that this one is positive. Now remember, these two together, they add up to 30 meters. So now how would you add a positive and a negative? It's by subtracting the two instead of adding the two, because you know that technically when you subtract, you're making up for the negative sign of the other, and therefore it becomes positive. So now we can say, but we know that SA minus SB equals 30 meters. Okay, let's just say 30. Why am I putting a minus, like I said? Because the displacement, if you just choose any number for the time, you will notice that the answer you will get here is negative, and therefore it won't match a positive answer there, because if you just add them together, it's going to be this one minus this one, and therefore you won't get the 30. Okay, so we have to make up for that. To add, we have to subtract. Okay, I hope you understand. So now we're going to say now 16t minus 4,9 t squared minus, now this SB, we know that we found that, okay, we're going to just put it there, 8 t minus 4,9 t squared plus 4,1. Alright. So we could equals 30. Not a problem. Alright. That was the implication, which also implies that we have 16t minus 4,9 t squared minus 0,8 t plus 4,9 t squared minus 4,1. This is when you distribute the negative sign inside, equals 30. Alright, not a problem. So immediately you can see 4,9 cancels the 4,9, and then now we have 16 minus 0,8. So this implies that we will have a situation here where we have 16 minus 0,8. So I get 15,2 t. Okay, and then what do we need? We need to transpose this negative to the other side. So we can simply say equals 34,1, because 30 plus 4,1 is just 34,1. Alright, so we transpose this one to the 30. Therefore t will be now whatever the ratio we get from there. Alright, 1 divided by 15,2. So what I get here is 2,24 seconds. Alright, that's the answer to the time. But remember, this is not the answer. We know now, once we know the time, we can now put back the time in that equation, right? And we have solved the displacement story. We can now say substitute t equals 2,24 in 1, which will give us now SA will be given by 16 into 2,24 minus 4,9 into, oops, you can see, into 2,24 squared. Alright, so this will just give us the answer. We don't have to sweat here. So we're going to have here 16 times 2,24, which gives us 35,84 minus, and then here we're going to have here 4,9 into 2,24 squared. So here I get 24,59, and then we can do the math now. 35,84 minus 24,59, I get 11,25 meters. Alright, so this tells us now that is the displacement of A when these two meet. You can see it's positive because it shows upward as positive, so nothing is silly, everything matches here. And displacement, you can say above the ground if you want, or upward if you will, because remember this is displacement. They didn't really specify that they're talking about distance or displacement, so we'll just assume this is displacement, which is a vector, so we need to say the direction. So these are some of the hard ones to figure out. Okay, all right, not a problem. So 6 marks. Whoa. Okay, maybe let's give 2 marks for that, and then we can give 2 marks for this one as well. Already 4 marks. Yeah. Okay, let's forget about too many marks here. Formally, not gonna give marks, so we give just a mark there and then a mark there. Alright, and maybe a mark here. This one was a bit comprehensive. There was this t minus 1, which I think makes it complicated, so we have 3 marks. And then I think we have the 4th mark there, and by getting the time, the 5th mark, and then the final mark. Again, vectors, you must specify direction, but if they told you that the distance, instead of saying how high, because how high can mean displacement, can mean distance, so it's not specific, so cover everything. But in the end you have 6 marks. That was a bit of a hard 13 marks to get. The last question would really kill you, I think, but it's a nice one to think about because it gives you a bit of some flavor. So I think we're almost an hour from, the beginning, but let's do one more question and cut it and then do the other one. All right, no problem. Let's just do question 4 and then we'll do another 4 and see where it takes us to. All right, now here's another thing. So there's a bit of work for these questions before, so yeah, that's why it's all stained. Anyway, it says a bullet of mass 20 grams. Now once you see grams, usually the SI unit that we use in physics is kgs. So immediately convert that. So 20 is 0,02, because what you do, you just say 20 divided by 1000, okay? Gives us 0,02 kgs, okay? Is fired from a stationary rifle of mass 3 kilograms, okay? No problem. Assume that the bullet moves horizontally. Immediately after firing, the rifle recoils, moves back with a velocity of 1.4 meters per second. Now again, you know that once you hear this thing with an explosion somewhere, it has something to do with collisions, and this is momentum or conservation of linear momentum. So you immediately know that you need to choose directions here, okay? So 4.1 says calculate the speed at which the bullet leaves the rifle. So this is after they collided, isn't it, with the gases in the chamber. Not a problem. Let's start. Question 4. We're going to try and move faster here so that we don't lose too much time. So 4.1, we now know that we have a gun here whatever it looks like. And then it has a bullet. This is before. It's stationary, so it's 3 kgs. And that one we know is 0.02 kgs, okay? And they are both stationary. And then after the collision, we now have the gun. Yeah, it looks ugly, man. Don't worry though. We have the gun, which is 3 kgs, but it's moving. So we're going to choose to the left as negative and to the right as positive. So always state your choices there. So now this is going to be 1.4 meters per second because it's to the left. But now we have our bullet going in that direction. Yes, we know it's 0.02 kgs, but the v is the question mark. We don't know. Alright, but it's in the positive direction. Alright, so to answer this question, we just say P before equals P after. P means momentum, okay? But now the P before, because these two were stationary, so it's going to be them together. It's going to be 3 plus 0.02 times 0 because they were stationary equals P after. It's going to be now the two momenta for the two structures added together. So it's going to be this one 3 times minus 1.4, alright, plus this one is going to be 0.02 V, because we don't know. Maybe say VB to say bullet, okay? Alright, not a problem. So I've already, substituted, because we can't really do a hypothetical situation forever. So this also implies, now all you can do here is to make this one a leading situation. Either way, we don't have any issues. So 0.02 VB, alright, will be equal to, remember that is 0. So just transpose that. Okay, let's see what is that. 3 times 1.4. But pay attention to the sign. It's going to be minus. Sorry, this is negative here, but when it comes to the other side, when you now transposing it, it becomes 4.2. Okay? And therefore we know that the velocity of the bullet is going to be 4.2 divided by 0.02, which is now 210 meters per second. And this is to the right. So you can just use that arrow there to signify the direction of motion. Alright, no problem. I think that was fairly easy. Always know the principle of conservation of linear momentum. So you get a mark for this, mark for the substitution. How many marks were they offering there? 4 marks. Okay, not a problem. So I think 3 marks over there. Where else? Maybe for choosing this direction, or 0. Can decide, can give it here. Sometimes the 4th mark, it's very debatable if you got the answer right, but if you did not, then the marking guidelines become crucial. Alright, so we have our first 4 marks for this question. Now it says a bullet strikes a stationary wooden block fixed to a flat horizontal table. Now when it is fixed, it means there won't be a movement. Okay, the bullet is either going to go through or it's going to get stuck. Okay, the bullet is brought to rest after traveling a distance of 0.4 meters into the block. Okay, I've already worked here a bit. So this is going to be 0.4. That is the distance. As it enters at the speed it left the rifle. So which is going to be 210, which is that one over there. And then it will travel this distance and come to rest there. Rest is 0 meters per second. Okay, no problem. Now it says calculate the magnitude of the average force exerted by the block on the bullet. Again, we've made our choice already that to the right was positive, to the left was negative. So 4.2. All we know is that for us to know a lot about the force. We already know the mass of the bullet, but we don't know the deceleration that it experienced, because deceleration, remember, we know that when a resultant force is applied on an object, because the bullet is going to have a force being applied by the block, which is going to be the resultant force. Why? Because that bullet is going to start decelerating in the direction of the force. So if we find the acceleration, we literally will just multiply with the mass and we have the force. No problem. So now we need to find that deceleration. But now we don't know time. We only have the initial velocity, the final velocity, which is 0, and the displacement. So the best one is to use this formula. V squared equals u squared plus 2as. Of course, this is now linear motion, so I'm going to use acceleration instead of gravitational situation. But the final velocity is 0. Initial velocity is 210, but this is squared, okay? Plus 2, the displacement was 0,4 times s, which is what we don't know, okay? Great. This implies now, so you can transpose that one over there. So we now know that 0,4 times 2 is 0,8, right? Just be sure. Sometimes look, these things may look easy. 0,8s equals, now you can transpose that. It's going to be minus 210 squared. Oof. Gonna be a big number. So it's 44100. Okay. Okay, this is 44,100. Okay, not a problem. Then we can therefore say that displacement. What am I doing? What am I doing? This is A, man. Oh, my brain is tired. Actually, I'm from work, so my mind is like fried. But yeah, maths, it's something you don't want to be tired for. This is A equals, and as you can see, it's going to be negative, all right? 44100 divided by 0,8, we get minus 55125 meters per second squared. Now remember, the negative sign tells us it's in the opposite direction, so we don't have to worry about that. We can say, but we know that according to Newton's second law, the resultant force equals the mass and acceleration, and this is for the bullet, right? Now the force, the resultant force on the bullet, is that force being applied by the block, is going to be the mass of the bullet, which is 0,02, multiplied by the acceleration of the bullet, which is 55,125 meters per second squared. Okay, now we have 55,125 times 0,02. So I get here 1102,5 newtons, but this is negative, okay? Which I can simply write 1102,5 newtons to the left. Or you can leave it as minus, because that sign essentially helps us to know the direction of that force. Okay, not a problem. So we are right where we want to be. Okay, how many marks were they giving here? 5 marks. Okay, I know that that is important, and this acceleration is important, and this formula is important, and the correct substitution and the answer. But remember, when we want the force, we know that we're talking vectors, so the direction must never be forgotten. So there's the 5 marks, okay? Not a problem. You know, for this kind of a question, someone who thinks otherwise and say, but I didn't think Newton's laws of motion could be coupled with momentum. Yes, they can be. Let's say, for example, you didn't think about this. Here you would struggle a little bit, I'll show you. If you do it otherwise, but you can still do it. Let's just try and show it, because we are learning now. We're not really about the answers per se, but it's just a technique. Now, this step is important because you still need the acceleration, all right? But the next one, we want the time it took for the bullet to come to a standstill. You will understand why I want the time. So we are going to simply say, fine, if we say v equals u plus at, we want the time. V was 0, u was 210, minus the acceleration is this one, 55,125 t. Okay, we want time. Therefore, t will be, we transpose this and divide by that. So 210 divide by 55,125. I get this silly expression 3,81 times 10 to the minus 3. That means there were many zeros, so it just did it in the scientific notation. This is seconds, all right? Not a problem. So we know if you didn't think about it, you think of it as an impulse, because this is essentially a question about an impulse anyway, which is nothing but Newton's second law. An impulse, we know that F delta t is the change in momentum of the bullet, okay, because that's the force being applied on the bullet. And then this F delta t, now the t is this one, is 3,81 times 10 to the minus 3 equals, now the change in momentum is just going to be the mass of the bullet. Okay, let's just put the number 0,02. Yo, I don't know why I did that, but it's 0,02 here. Okay, inside it's going to be 0 minus 210. Okay, that's all, the change in momentum. And then it tells us now that the force will be this product here divided by that time. So look at this, it's going to be 0,02 times 210. Of course it's going to be negative, right? 0,02 times 210. I don't know what I did, but I did something silly there. So it's minus 4,2. And then we divide this by 3,81 to the minus 3. So I still get minus 1102, but this time it gives me 36, which is roughly 36 newtons. All right, so this is comparable because I mean it's 11, it's all about rounding off anyway. So some answers are not going to be exactly accurate, but you will get something very close to the answer. And as you can see here, again, this part gives you your first 2 marks, and then here you will get say a mark here, but this one is important, and then the answer. So you will get 1, 2, 3, 4, 5. So you will still have your 5 marks, but this step here is key to doing anything in this question, at least so far. All right, I hope you understood that one as well. It wasn't too complicated, but a little bit elusive. It says now, how does the magnitude of the force calculated in question 4.2 compare to the magnitude of the force exerted by the bullet on the block? Write down only larger than, smaller than, or the same. And we know that according to Newton's third law, where there's a pull, where there's an action, there's a reaction. So if the block applied this force, which is 1,102.5 newtons to the left, the bullet has simply done the same to the block, okay, but in the opposite direction. So it's going to be the same. And if you don't know why, you can just say Newton 3 law. Okay, Newton's third law is your explanation. If they said substantiate your answer, you would state Newton's third law. But now they just said the same, so you only get 1 mark for that. All right, so there's our 10 marks. Again, not such an easy 10 marks. We did a little bit of work in there. All right. Okay, guys, I hope you have enjoyed those 4 questions so far. Okay, we did 3 anyway. So I hope you have enjoyed them, and let's see in the next video when we continue with this paper, doing question 5 to probably 8, depending on how quick we're going to be going through them. We'll see, but the target is to at least go an hour. All right. Cool. See you just shortly.